This is x squared, which means it's a parabola. Okay, the 1/2 means it's going to be wider, okay, or vertically shrunk. And the -2 means down 2. So I'm going to shift it down 2 places, and I'm going to make it wider than normal, okay? And I'm either going to write wide or shrunk, because on your test, this is one of those questions where you're just going to take a picture of the graph and upload that as your answer. And I need to know that you meant to make that wide because you're not graphing the original parent function and also that, okay? Number 5 is your absolute value. So this is a V. The negative on the front means upside down. The 5 means narrow or vertically stretch. The -1 means right 1, and the +2 means up 2. Now, that's a lot of transformations, and that's pretty much on level with a question that you would get. You're not going to get just like one transformation. So I'm going to go right 1. I'm going to go up 2. I'm going to point it down, and I'm going to make it narrow. Or stretched. Questions? Okay. All right, so we're going to finish 1-5 today, which will be the end of the notes that we'll cover for your test, again, which is next Thursday. It's going to cover B1 through 1-5. So we left off yesterday with the combining of functions. We took first we did with the graphs, then we added to, subtracted, multiplied, divide, and talked about the domain, right? Now we're going to talk about, which I think is easier, what do I do if those are numbers instead of actual equations, right? So remember that f of g of -1, like this, it can also be written as f open dot g -1. And either way we go right to left. What this means is work the inside parentheses here, or take -1, plug it into the g of x. So I'd get 4 minus a -1 squared, 4 minus 1, which is 3. And then I'm going to find f of 3. So I'm going to take 3, plug it into the f. And I get 2 times 3 minus 3, 6 minus 3, which is 3. This is like my example. I don't know. I had 3s on the brain apparently for these examples. You're going to see it a bunch. But just keep in mind that that answer is just a single number. So the mistakes people make is giving me 2-part answers like 3 and 3. It's not. The ending answer is what you get by taking what you got from the first one, plugging it into the one on the outside, which in this case was f. So it's just one number. For the second one, it's the reverse order. Now I'm doing f first, right? So if I wanted to write this in parentheses, this would be g of f of 2. So I'm going to take 2, and I'm going to plug it into the f of x, and I get 2 times 2 minus 3, 4 minus 3, which is 1. And then I have to find g of 1. So I'm going to take 1, I'm going to plug it into the g of x, and I get 4 minus 1 squared, 4 minus 1, which is 3. Again, that's the overall answer, just 3, not 1, then 3, just 3. Now what we could have done is found g of f of x first. Like we did yesterday, I could have taken f of x, plugged it into the g of x, expanded it, foiled it, combined my like terms, and then plugged 2 in. But in my opinion, it's way easier to do it the way that we did it, which is why I teach it that way, okay? So you can take the equations, plug one into the other, whichever way it's supposed to be, simplify, and then plug the value in, and you'll only have to plug the value in once. Or you take the value, plug it into the one on the right, take that answer, plug it into the one on the left.
Does this only work when it's multiplying, like the g of f, or?
So no, because this doesn't mean multiply, right? That means take it, plug it in, plug it in. So these could have been 2 completely different things. I could have said g of x was the square root of x, and then I'd have to take -1, plug it into that, get an answer, plug it in, which wouldn't work because it's negative, but you get the point. I could have done with +1. Does that make sense?
Yeah.
Yeah, okay. The type of function at the beginning will be whatever it wants to be, okay? But just pay attention to the order. That's what I would say, is make sure you go innermost parentheses out or right to left, opposite of what your brain reads.
Okay, so inner would be as if you do the g first, like because g is in the inside. So you plug that in, then you find it, and then you plug it into the f of x?
Exactly.
Okay.
All right, so let's do ones with actual equations, right? This says find A, f of g, b, g of f. Find the domain of each function and of the composite, all right? So we're going to start, I'm just going to do f of g first. So A is f of g. Technically, there would be an x there. There's no number here, which means I have to take g of x and plug it in to f of x. So f of g of x would be 1 over x plus 3. So I'm taking the 1 on the right, plugging it into 1 on the left. This time I don't have values, so the variables are going to stay there. The second one, B, says find g of f. Now I'm taking f of x and plugging it in to the g of x. So this would be 1 over x plus 3. You with me so far? Now it says find the domain of each function and of each composite. So for the first initial ones, f of x, okay, is 1 over x. Is there a domain restriction there, or is it all real numbers?
A restriction?
There's a restriction. Why?
It's in the denominator of a fraction.
Good. There's a variable in the denominator. So for this one, my domain would be x cannot equal, oh, I lost my, x cannot equal 0, right? So it would be negative infinity to 0, union 0 to positive infinity. That's the domain. Sorry, go ahead, Matt.
No, my iPad just crashed.
That's okay.
I don't know why.
That's okay. That would be, we're just doing domain of the function. So we went back to f of x, we're finding the domain of that one. Then I want to do domain of g of x. Is there a domain restriction this time? Is there a variable underneath in the denominator? Nope. Is there a variable under square root? Nope. Or the combination, which means no, which means the domain there would be negative infinity to positive infinity. You with me so far? So now when I look at the composite functions, oh, I erased this, okay? You have to say, are there any additional domain restrictions? So what happens when I take g and I plug it into x of the f? I got this, 1 over x plus 3. Is there a new restriction?
Yes.
What is it?
It can't be -3.
Good. So because I took the g and I plugged it into the f, and I can technically take something, plug it in here, and then plug that in there. When you are looking at the domain of the entire thing, if there's a domain restriction on the one you're plugging in, so the one on the right, if there is a domain restriction on that, I have to carry it down and then add to it what might have happened at the end. If there's no domain restriction here, which there wasn't, then I only need to worry about the one that I just got from what's the composite, which means the domain restriction here is negative infinity to -3, -3 to positive infinity. So I'm going to say that again. If there's a domain restriction on the one you plug in, so the one on the right, you have to say whatever that is and whatever you'd get from the composite function. Because g of x didn't have a domain restriction here, I'm only looking at the composite function's restriction and saying that that is the domain of this function. Now look at b. We took f and plugged it into g. So I have to look back at the f of x and say, was there a domain restriction? The answer is yes. X could not equal 0 from the get-go. Now I have to look at my new composite function and say, is there a new restriction? There's not, it's the same. So then the domain of this is negative infinity to 0, union 0 to positive infinity. So if my original one that I plug in, so the one on the right, has a domain restriction, it gets carried down with your function. So that's why we took it from here for B, because f was plugged in. Then we look at the composite function and say, is there another one? If there's another one, we have to use both restrictions. Questions on that one? So that's domain of a composite function.
Oh, so you have to find the domain restriction for g of x first.
Correct. So g of x, because I'm only doing one, I didn't do g of f and f of g. I really only need to go back to the one I'm plugging in, which is the g of x, and say this would have to be greater than or equal to -3, right? Then I would actually do the composite function. So I'm going to take this and plug it in there. 1 over the square root of x plus 3. Now, this gets carried down, but I also have to look, oh, there's a new one here because I put it in the denominator. Now it can't equal -3. So it restricts it even further, and I would say now x has to be greater than -3, and my domain is going to be -3 to positive infinity.
Okay.
Does that make sense?
Yeah.
Okay, perfect. You're welcome. All right, now we're going to use... Somebody have a question? Go ahead.
Yeah.
All right, so now we're back to graphs, right? So this is, I know it's really fuzzy. It's the best I could do. I wasn't recreating this crap. All right, it says use the graphs of f and g to evaluate the functions. So this first one is y equals f of x. This second one is y equals g of x. So two separate graphs. Now number 1 says to find f plus g of 3. If we had equations, we could add the f of g and the f of x and the g of x together equation-wise, combine like terms, and then plug in the 3. But we don't have that scenario. So this is the same as saying find f of 3 and add it to g of 3. So I go to my graphs. I find where f of 3 is. Remember, that's where x is 3, and you give the y, which would be here. That's 2. Then I go to g of 3, which is here, find the y, that's 1, and because it told me to add, I'm going to add them together. Now go to b. b says f over g of 2. So this is f of 2 over g of 2. So now I go to f of 2, which is here, get that y, which is 0. It really doesn't matter what happens after this, but I'm going to continue because if it was a different number, it would. G of 2 is here. Get the y of that, that's 2. 0 divided by 2 is 0. Go to 2a. That is an f open dot g. F of g of 2. So this means find f of g of 2. Go to g of 2 first. Figure out what that is. Remember the g is 2 here, which means the answer there's 2. Then find f of that. F of 2 is 0. And the last one, again, I know it's fuzzy, but it's g of f of 2. Now I've reversed that order. I want to find f of 2 first. F of 2 is 0. And then I want to find g of 0. Here's my 0. G of 0 is 4. So work right to left, or innermost parentheses left. Questions on those? So I'm going to go over this next question, but it's not on your homework, and it's not, this is a great, like, kind of like a higher level thinking, but silly, standardized test-ish kind of question, but it's not on the homework and it won't be on your test, okay? So the pressure's off on this one. It says find two functions f and g such that f of g of x equals h of x. And it says, notice that there's many answers, which is why I took it off because it's a pain in that butt to grade. So the question is, how do I find f of g of x in such a way that my answer would be this? Okay?
Mr. Supervisor?
Yeah.
Are you writing?
Is there-
Oh, it's paused. Thank you. Hang on. Why did you pause? There we go. Now do you see it? Yes? Okay. So again, I'm trying to find two functions, f of x and g of x, that when I take g of x and I plug it into f of x, I end up with 2x plus 1 squared. So for me, like anytime I would see a question like this, I would think the squared is almost like a grouping, right? So if I could take anything that's inside this and make it one function, then I would want to do whatever the operation is outside it as the second function. So if I made the inner one, the one that's inside the parentheses, if I made g of x equal to 2x plus 1, and I wanted to end up with it being 2x plus 1 squared, then I could make f of x x squared. And what would happen is if I wanted to find g of f of x, or sorry, f of g of x, because that's the order it gave me, I would take this, I would plug it into here, and it would look like 2x plus 1 squared. Does that make sense? So you got to understand the composite, the order of the composite in order to answer this question. This is a good standardized test question because maybe it will give you choices, like which one would it be. It's bad as an open-ended one because there's more than one answer sometimes, okay? But that's what you're trying to think of. How could I take what's inside the parentheses, raise it to a power? It would be the same if I said like the absolute value of 2x plus 1. My g of x could still be 2x plus 1. And my h or my f of x would be the absolute value of x. So whatever the grouping symbol is what I usually look to replace. And you take one, plug it into the other. But again, I took this off of the homework because it's confusing when you have more than one answer. And it's not going to be on your test. The last thing that will be on your test is... So that wraps up 1-5. If you want, I will actually publish it if you want to get started on the review for your test. But your test is Thursday of next week. So the 1-5 homework is due on Tuesday. Tuesday, I'll go over the homework. We'll do the warm-up for 1-5, and then we will start your review. My goal on Tuesday is to try to help build like almost like a reference sheet for you for Thursday so that you're not digging through your notes because you simply will not have time. And then on Wednesday, I'll build some sort of an assignment in which we can practice the upload of the picture again, all that stuff, kind of work through the kinks so that on Thursday, you're like, oh, I totally know how to do this. I can work through this pretty quick. I'm not stressed about the environment. I don't want you to be stressed about the environment. Okay, I want you to focus on the content. So that will be our plan for next week. Any questions for me?